Hi my friend, welcome to Choice Tech, and in this video of Choice Tech we are going to look into the solution number 2 of the K-Palindrome problem. Now I have already made a video on K-Palindrome in which we solved this problem using an algorithm similar to minimum edit distance. You can watch it, but I am presenting to you the second solution to this interesting problem so that you have more options to solve this problem. Now we are going to take a look at the problem statement of K-Palindrome problem. So you are given a string, and that string is ABC, DEC, BA, and a variable which is K, the value of which is 2. You need to determine if this string is a K-Palindrome or not. Now, if you don't know what a K-Palindrome is, it means that can this string ABC, DEC, BA be converted into a palindrome by removing k characters from it or less than k characters from it. Alright, so the value of k is 2. Can I convert this string into a palindrome by removing 2 characters from it or 1 character from it? Okay, so value less than equal to k. Now as you can see that if we remove B and E from this string, we are going to get a palindrome. This means that by removing 2 characters we are getting the palindrome, and k is 2. So this is a k palindrome. Alright. Now the solution which I am going to present to you is, this is our string, and if we find the length of the longest palindromic subsequence of this string. So what is the longest palindromic subsequence? It is ACDCA. Now its length is 5. Now the total number of characters in this string is 7. So if we subtract 5 from 7, we are going to get 2. Now that 2 is equal to k. So the thing is that if we subtract the length of the longest palindromic subsequence from the total length of the string, and the value we get, if that is equal to or less than k, then it's a k palindrome. So now we are going to switch to our framework where we are going to solve this problem, where we are going to find the length of the longest palindromic subsequence. Now if you are new to my channel and haven't subscribed yet, then do hit the subscribe button and hit the bell icon. This way you will get notified whenever I release new videos like this in future. So let's switch to the framework. So here we are at our framework. We are going to fill this matrix over here, and this cell is going to give us the length of the longest palindromic subsequence. Now you can see k is equal to 2 and the length of the string is 7. We are going to fill the length of the LPS here, and string minus LPS is going to give us the answer, which has to be less than or equal to k. Now I have already created a video on longest palindromic subsequence in which I have explained the intuition, and I have done enough brainstorming and I have explained the entire problem in detail. You can refer to that if you want to learn the problem in detail. I'll start from the lowest subproblem here. So when a is equal to a, it is going to give me 1 over here. Then when b is equal to b, then it's going to give me 1 over here. When c is equal to c, it's going to be 1. When d is equal to d, then it's going to be 1. Similarly, it is going to be 1 for the subsequent cells which are diagonal to each other. Now we are going to populate this cell. Now this cell is going to be the maximum value of this cell, A or B. So this cell. So what is maximum between these two values? It is 1. So it is the maximum of A and the maximum of B. Now similarly, this cell is going to be the maximum of B and the maximum of C. So this is also going to be 1. Similarly, all these cells are going to be 1. Okay, take a look here, it will be maximum of C and maximum of A. So 1, 1, it is going to give us 1. Now over here, this is going to be the maximum of AB and BC. So AB is 1 and BC is also 1. So this is going to give me 1. Similarly, this is going to be the maximum of BC and CD. So BC is 1 and CD is also 1. So this is going to give me 1. Similarly, I am going to get 1 over here. Okay. Now over here, the subproblem changes to ABCD. So it is going to be the maximum of ABC and BCD. So ABC is 1 and BCD is 1. So I'm going to get 1 over here. Now this is the subproblem BCD. So it is going to be the maximum of BCD and CDE. So BCD is 1 and CD is also 1. So I'm going to get 1 over here. Now over here the problem changes to CDEC. So you can see that this C and this C are equal, or if we are viewing the subproblem like this, then you can see C and C are equal. That means here we have a palindrome. So what happens in this case? The value of DE, which is DE, and the value is 1, it will be added to 2. So I will get 3 over here. Why added to 2? Because we have got 2 characters which are equal. Okay. I have explained everything in detail in the videos which I have made on longest palindromic subsequence. You can refer to that before watching this video, or you can refer to that after watching this video as well. Alright, it's for your understanding and it's your choice. Over here we have DECA. Now D and A are not matching. Okay, like in this problem we had a match. So it will be the maximum of DEC and ECA. So DEC is 1 and ECA is 1. So we are going to get 1 over here. Now the length of the subproblem increases to 5. So we have A, B, C, D, E. So A and E are not matching. Okay, so it is going to be the maximum of A, B, C, D and B, C, D, E. Alright. So A, B, C, D is 1 and B, C, D, E is 1. So we are going to get 1 over here. Alright. Then the subproblem changes to B, C, D, E, C. So B and C are not matching. You can refer like that. The algorithm is actually going to refer the match like this. So it is going to be the maximum of either B, C, D, E or and C, D, E, C. Alright. So B, C, D, E is 1, but C, D, C, E, C, D, E, C, that means C, D, E, C is 3. So the maximum between these two cells is 3. So I am going to populate 3 over here. Okay. Now here the subproblem changes to CDECA. Okay. Now C doesn't match with A, so it will be the maximum of CDEC and DECA. So CDEC is 3 and DECA is 1. So maximum is 3. So I'm going to populate 3 over here. Okay. Now the length of the subproblem increases to 6. So we have A, B, C, D, E, C. So A and C are not matching, A and C. So it is going to be the maximum of A, B, C, D, E and B, C, D, E, C. So A, B, C, D, E, A, B, C, D, E. So it is 1 and B, C, D, E, C. So it is 3. So which is maximum? 3. Okay. Alright. Alright. Great. Now over here we have the subproblem changed to BCDECA. So it is going to be the maximum of BCDEC and CDECA. So BCDEC is 3 and CDECA is also 3. So we are going to get 3 over here. Okay. Now the subproblem is actually our problem ABCDECA. So as you can see, A and A match. A and A match. So what happens in this case? 2 will be added to the value of the subproblem BCDEC. So what is BCDEC? It is 3. Alright. So 2 added to 3 is going to give me 5. And this is the length of the longest palindromic subsequence. Now I'm going to put 5 over here, and this is going to give me 2 as the answer. Now since this 2 is equal to K, hence this string is a K-Palindrome. Okay, this is our solution number 2. Now let's take a look at the algorithm. So the algorithm will be of the longest palindromic subsequence. So here is the algorithm of LPS. If Ti is equal to Tj, then Tij is going to be 2 plus Ti plus 1 j minus 1. Else Tij is going to be maximum of Ti plus 1 j and Ti j minus 1. The time complexity of this LPS algorithm is O(n) square. So this concludes this video. I hope you enjoyed watching this video. I hope you learned from this video. Do give it a thumbs up, and I look forward to help you with programming and algorithms, and only for this video. Goodbye.